Okay, so welcome to this video. So in this video, we're also going now to be solving another examinable question. Yeah, so this is also from a past paper. So this question is saying find d over dx of x to the power sine x. So basically, we're just going to apply the same concepts that we applied in the previous video. Yeah, so if you didn't watch that video, I would advise you go back and watch that video. And you get the concept from there, and then you come and watch this video. Yeah, that way we're going to cement the understanding. Okay, so find d over dx. So now in this video I'll be a little bit fast. Yeah, because I think I explained everything in that video. So I think maybe I'll drop the link, yeah, in the description to that video so that you go and watch that video. Okay, so it is saying differentiate d over dx of x to the power sine x. So basically you're going to do the same. We equate the given function to the what? To the y. So we're going to say y being equal to the given function, which is x sine x. So we're going to say this. We are simply going to say d over dx, open bracket, y being equal to the given function now, which is that one, x to the power sine x. So it is x to the power sine x, like that. Okay, so that is x. Yeah. So now we know that we have a power which is sine x, but we want it to do what? To become the coefficient. So what we do is we introduce ln x to rather ln to the both sides of left hand side part where there's y and the right hand side part where there's x to the power sine x, so that we drop that power which is sine x. So it is going to be like this. So the expression will be d over dx of, now if we introduce ln to this part, we're going to have ln y being equal to, then this part we're going to have ln, then the same expression that we had, which was x to the power sine x, like that. Yeah, so what we do now, we can drop that power down because we have a ln there, which is a log. Okay, so we can have, so I'll just slide like this, ln y being equal to sin x multiplied by ln x. So multiplied by ln x, like this. Okay, so we are having this now, sin x multiplied by ln x. So what we are now left just to do is we differentiate that. So that is the product rule. If we differentiate using product rule, we are going to have what? 1 over x sin x plus cos x ln x. So this is now where I said if you didn't watch that video, so because yeah, in this video I'll just be a little bit fast. Yeah, so if you didn't watch that video, the previous video, you can just go and rewatch it, then you come back to this and watch so that you get the concept in full. Yeah, so I won't explain like in full, but I'll show you how to do it. So sin x ln x, we use that same formula that I used in that previous video, which is uv prime plus vu prime. Okay, so if we take our first expression there, or maybe our first value, so which is sin x, so we take it the way it is. So if we take the sin x, then we differentiate the second item, which is 1. So it will be, if we differentiate this one, we're going to have 1 over x, then we say plus, then we differentiate now the second item. So we take the second item the way it is, we write it here, which is ln x, then we differentiate now. Okay, so that is x. So then we differentiate now, we multiply it by the differentiation of the what? The first term, which is sin x. If we differentiate sin x, what do we get? So differentiating sin x gives us what? Cos x. Yeah, very simple. Cos x like that. Okay, so this expression we are having, so yeah, now to make it like look more interesting, more professional, yeah, we can, so this one we can take it as a coefficient 1 over x, so I can write it right there. Yeah, so that we have 1 over x sine x plus cos x ln x. So we also take this part to here. Yeah, hope we get it will be like this. So this part we are having ln y. Don't forget we are having ln y being equal to. Then the right hand side part now. After differentiating, we are having 1 over x, then sine x, then plus cos x, then ln x, like that. So we're having this now. So what are we going to do now? The left hand side part, mind you, we haven't differentiated it. Yeah, we we have only differentiated the right hand side part. So it is now the time to differentiate the left hand side part. Yeah. So if we differentiate this part using implicit differentiation, because this is implicit differentiation, yeah, we're having y there and we're differentiating with respect to what? To the x. So it is going to be 1 over y. So it is going to be 1 over y. 1 over y, but we add dy over dx like that. So this will be equal to everything which is on this side, which is 1 over x, then 1 over x sine x, then plus cos x ln x, like that. We are not done, but we are almost there. Yeah, the only thing which is remaining is to make dy dx the subject. So if we make dy dx, meaning we're going to multiply the whole expression, this expression that we're having here, by y. So this side and this side, we now multiply by what? By y, so that we get rid of this y which is here. Yeah, so we are going to have here on the left hand side part, we're going to have dy over dx. Then the right hand side part is going to be multiplied by what? By the value of y. Yeah, so okay, let me write this on the next page. So it will be like this: dy over dx. So dy over dx will be equal to y. Yeah, because mind you, this side we had 1 over y, but it has been cancelled or divided. Y over y, it is 1. 1 times dy over dx, it is dy over dx. That's the reason. So now this side we are remaining with y multiplied by everything which was on the right hand side part, which was y over x. Then the everything now sine x, then plus cos x multiplied by what? Ln x, like that. Okay, yeah, we are done, almost there. One more step. Yeah, don't forget the value of y there. We didn't have y at first, we just introduced it. So what is the value of y? Take back the value of y and put it there, then you are done. Yeah, these questions are actually very simple. Yeah, but without practice, well, yeah, nothing is very simple. So dy over dx will be equal to, so the value of y, what was the value of y? So questions like this, the value of y is always the what? The actual question, the actual expression, the given function which was in the question. Yeah, because that's the expression that we equated to what? To y. We said y is equal to the given function. So the given function, it is the function that we had equated to y. So where there is y, we can now put back the function which was there, which is x to the power sine x, which is x to the power sine x, like that. So this is the value of y. We now say open brackets. So this is just the value of y. We now write everything the way it is, and then we are done. Yeah. So we have 1 over x, then sine x, then we say plus cos x, then we say ln x, like this. We are done. So that's the answer.